What's up, you guys? What's up, you guys? This is 487. No camera with my face on this one because I just want to get to where we can get this one active and out to you quickly. So to do page 487, you're going to need page 486, and you're going to need the flow proof that we built from page 486. So every single step of the flow proof is going to find its way onto the two-column proof here. Reminder, we're doing the proof that shows that these lines are parallel and this line section is half as big as this one. That's the whole idea of something called the mid-segment, that the lines are going to be parallel and that the mid-segment is half of the other one. So I've got our two-column proof, going to set this off to the side, and I'm going to start writing down step by step, given by given. So first of all, J is the midpoint of segment MD. I'm going to abbreviate midpoint like so. G is the midpoint of MS. And that's because given. And it's probably helpful after every single statement and reason to draw a line so we know that was step one. And I should use a ruler. I feel bad that I'm already not doing that. Since this has been discussed, that's gone. That's now off the table. One thing I got to keep in remember is that these need to be in the proper order. So I'm going to hopefully make them be in the proper order for remembering for later. Now, the second step, you have your choice. You could work left to right, but you're still working top down. And what I noticed, this is never really even used unless it's used all the way down here. So maybe I'll leave that one in there for the moment, but I'm going to talk about this one as our second statement. JM is congruent. Let's get that where it's visible. Get this where this is visible. JM is congruent to JD, and GS is congruent to GM. And the reason, literally from the statement up above, definition of midpoint. Okay, so that's going to be our second row that we've talked about. And something that was used in the statement there needs to be used in the reason over here. Okay, cross it. Following the arrow path, now I'm going to go ahead and I will bring this one into play now. I'll say JG is a mid-segment, although I'm still debating on where and ultimately how it's fully used. JG is a mid-segment of triangle MDS. This is because mid-segments, joining midpoints, there we go, joining midpoints creates mid-segments. Reminder, in that last video, we did an entire outline. This is the outline. This is the flow-proof outline of the problem. Then if I follow the arrow path, I can't say this box yet until this box has been said, and I'm going to switch the letters around. So now I'm going on to statement number 4, JD plus JM equals MD. JD plus JM equals MD. Okay, there's that. And then GS plus GM. Yeah, I say GM, that's right. GM equals SM. And the reason for that, we're just segment addition postulating. Segment addition postulate. Okay, that's statement 4. And in the outline, I used it, so I'm going to cross it. So if I follow my arrows, these two boxes now get to say this. JM plus JM equals MD. GM plus GM equals MS because of substitution. Something that was the same in both of these is going to be replaced now. So I have JM plus JM equals MD. And I have GM plus GM equals MS. Statement 5, reason, substitution. Okay, so crossing that one off. Now if I follow my arrows, everything is all pushing to this statement. So this is number 6. We have 2 JMs, because there they are, equals MD. And we have, so maybe an and would be nice to have here, and there, and here. 2 GMs, because there they are, and they're added, is going to equal MS. Statement 6. The reason? It's addition. When you have 2 things, just add them to make 2. Okay, and on our list from the outline, that's crossed out. Now we have this statement. We're going to divide both sides by 2, so that's going to be dividing 2 JMs to make 1 JM. So we're on statement 7 now. Let's get a little overlap on the video. Here we go, right level. There we go. So 1 JM equals a half of MD, and 1 GM equals a half MS because of the division property, dividing specifically by 2. Statement 7. And discussed. Following the arrows down to this one. I can't say this statement yet until I've got all arrows that point to it. But this was a pair of sides, another pair of sides, and this is going to be the angle. So I have to right now, remember angle M, right? Back in the diagram, angle M is used twice. So angle M is congruent to angle M by the reflexive property. It's literally just the definition of reflexive, but we have to say this property because we need to say an angle from the small triangle is equal to the angle from the big triangle. That's statement 8. And now last of all, not last of all, but ultimately because we've got these 2 sides are proportional, and this angle, which is between those 2 sides, is equal to the other angle, same one though. That means the triangle is similar to the other. So triangle JGM is similar to triangle DSM by side angle side similarity. Oh, sorry, there it is, all the way there. Statement 9. And cross it off. We have 2 left, 3 left. We have to say this, which means we can say this, and then we can also say this. So I might go second, third, or 1, 2, 3 in the final statements. Because the triangles are similar, then that means, for statement 10, that the angles in them, now by the way, the angle I'm talking about is this one and this one. Those are congruent angles. And they're congruent because in similar figures, the angles are congruent. So those are corresponding angles in similar triangles. And they must be congruent. Statement 10. Then, last of all, if the angles are congruent, then the lines are parallel. And if the triangles are similar, then the sides of those triangles, the remaining ones that I've got blue, we haven't talked about these 2 yet, or at least not in a sentence together, those 2 sides have to be proportional. And we already know the proportional amount, 1/2, which is what we needed to prove. There's a 1/2 relationship here. So statement 11 is finally at the end. JG is parallel to DS. The reason is the corresponding angles are congruent. So corresponding angles that are congruent create parallel sides. I should put congruent up here too. Sorry if you don't have room. Fit that in there. Congruent corresponding angles create parallel sides. That is my bell. That's not your bell. Oh my gosh, there's always no time at the end of the day to get this stuff done. So here it is, the last one. JG equals a half of DS. JG equals a half of DS. And that's because corresponding sides of similar triangles are proportional. finish the proof, put a little box at the bottom. So the entire flow proof has now been addressed, and we're talking about how we have mid-segments, and we're talking about how mid-segments are always half of the opposite side. So here it is from start to finish. I guess technically, from start to the middle level of work to finish. And then this is the entire proof. Thank you for watching this video. Hope it was informational. I'll see you in the next episode.